All right, today we'll be doing 1.4. This part where it says, I said this last time that it's not part of the chapter 1 review. I just forgot to take that off when I recreated the book. So that's not part. So just 1.4, summation notation. So what we're going to do is we're going to look at how to use it. We will use our calculator, so make sure you have your calculator out. So let's start with some notes. I'm going to go to the blank page that's right after this and do some notes first. So let's do that. Let's go to the next page. Okay. So on this page, I'm just going to add some notes to kind of help us to understand summation notation. So summation notation. So kind of like what we do when we talk about summation notation. So what if I asked you to add up all the numbers well, let me even be more specific, positive integers. There's a lot of numbers between there. I don't want fractions, I don't want decimals, I just want positive integers. From 1 to 105. So without a calculator, let's just say I don't want you to use a calculator right now. So you would just do 1 plus 2 plus 3 plus 4 plus ... plus 1 up to 104. Let's just go up to 105. So I want you to add all those numbers. Remember this ... means here it's should be only 3. I went a little crazy there. But this means just continuing the task. Okay, I'll write a lot of notes on this page, so I have more advantage of the paper being big in here. Okay, so now I'm going to talk about that. So if I wrote that down, I want you to kind of look at this as these are terms. Remember, when you're adding things together, these are called terms. And each term, we would like to say, this would be considered a sub 1, and a sub 2, a sub 3. So this is whatever this a is 1. It's the first term, and it's this first term of the slot right here. So like this position, okay? So what we do with all that to actually talk about the notation of it, okay? So let's look at the notation of it. So this is actually a sigma, Greek letter sigma, okay? And I'm asking you to go from I, starting with M and going up to N, and using a sub I. So that's just saying a sub M. I'm going to start with M, then I got to go to the next one. So like here, I started 1. Now to get to the next one, I had to add another one. So I did M plus 1, because this is increasing by 1. So it's M is 1. Now it's 1 plus 1, it's 2. And then I go again to 2, and I keep going and I keep going until I get to this final N here, and I just end with a sub N. Okay, that's just like the very generic, not generic, I want to say general form of it. And let me talk about what each part is called. So when you talk about the certain parts, we'll note this. Obviously, this is sigma, like I said. Okay. All right. This I is considered the index of summation. Okay. M and N are called bounds of the summation. Okay. So if I were to write it using what I wanted to up here. And I'm going to write this little 1 plus 2 plus 3. I'm going to write this here. And I'm going to use sigma notation. So I'm going to say that, here's my sigma. I'll use I equals. Okay, now what am I starting with though? I'm starting with 1. And where do I end? 105. Oh, there's that 8 there. So now, but what did I do each time? Okay, so that's telling me when I is 1, I'm going to do 1. And then keep going up, and keep going up, and keep going up, and adding until I get to 105. And then we would get an answer, but right now I'm just talking about what it looks like, okay? What I kind of want you to look at, that there are different ways notation can be written. Like this is, I don't always have to have this an index summation to be an I. The index of summation can be, you know, here's an example. I like this one I have here. I did I equals M to the N of A1 of AI. This could be the same as this. I could do J equals M up to N. And that's a J there. I can use K. It doesn't matter what the index of summation is, as long as you know where to put it in when you do your problem. We can use other Greek letters. Okay, so what I'm going to do is I'm going to go over to the next page, and we're going to do a few things on there with example A and B. 2, and I'm going to add my notes down here. You can add them anywhere you want. Again, it's just easier for me to be in one space to make sure I can go back to notes. So this is going to be writing a summation. So you're going to be given a scenario such as this. For example, if I had 14 plus 16 plus 18 plus 20 plus 22 plus ... plus 100. What I want you to do is I want you to write a summation. But we got to figure out, like we've always had something in there. So we know we would have a sigma. We know we would have to start with an I or N, whatever you want to do. So if I start with an I, and I'm going to have to go from some number to another number. But I got to figure it out, because like I don't always start at 1. Like we did in that second example, we started with 3. So what we want to do is we want to look at what pattern is happening, what's going on that you can see, okay? And you kind of look at what's in common. I'm going from 14, 16, 7. So these are what kind of numbers? They look even numbers, okay? Well, that means they're being multiplied by a 2. So if I say, okay, this looks like this is 2 times 7. And this one is 2 times 8. And 2 times 9. And this is all the way 2 times 11. And this is 2 times 50. So now we can see where we start and we end. So we know that every time what's repeating is a 2. So I know it's going to be there. Okay? Now, I know that I have to multiply 2 by 7. Then I got to go up to 7 to the 8. Well, if you remember from our notation, like our major up here at our information, we're adding, when we start with N, we add the next one. And then we add the next one. So if I'm starting with, I have a 7, then I'm adding 1, getting 8, then I'm adding 9 and 10. So I know this has to be a 7 up to 50. Okay? But then what goes inside that, this is your I's. Okay? So then I put an I right here. And that's it. Okay? So let's try one more. Let's try, I'm not saying they're all going to be always easy, but let's try this one. My next example. I have 3 plus 3 over 2, 3 squared over 2 plus 3 cubed over 3 plus dot 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 plus. Now this is just going to, not an exact number, it's going to variable, which is okay. Doesn't matter that it's an n, k, whatever we want, okay? So we just got to find a pattern, okay? Again, I know I have to have a summation. So here's my summation, okay? And I'm going to go from something. So I'm going to pick k this time. Now, I got to figure out what's going on. Well, I see a 2 and a 2, a 3 and a 3. And so these two have to be the same because that's an same variable, top and bottom at what? But this one doesn't show that. But if we think about it, if I'm going 2, 3, and so forth, it's probably going 4, 5, 6. This more than likely was a 1 and a 1 there, because 3 to the first power is 3. 3 divided by 3 is 1. I mean, yeah, 3 divided by 3. Excuse me, 3 divided by 1 is 3. And so therefore it's left there like that. So now we got to figure out, well, what do I start with? Well, I'm keep increasing by a 1. But where do I stop with? Well, this is not a number, but it's stopping at n, okay? Up here we had something to stop with. We had that 50, because that number is, this is a number, it's not a variable. That's okay. So then we're just going to stop it in, okay? But what's happened every time? Well, we know we have a 3, and I have to use this variable, so it's k over k, because I'm doing 3 to the first, and then I have a 3 down here. Here's 3 squared and a 2 down here, because that has to be increasing, so this has to be it. So there's your solution. Okay, so the next one we're going to do is we're going to talk about using our calculator with this. So I'm going to pause the video and bring the calculator in. We're going to go to the next page of notes. Okay, let me close that. Okay, so I'm going to do the first one, and I'm going to show you how we do it. We will get to the calculator part. I'll show you how we do this without a calculator and what exactly it means, okay? For some reason, these are shoved close together, so I apologize. I'm going to scoot way over here to do A. Okay, so what this means is that n equals 3, and I'm going to go from 3 to 7, and have a 5n minus 2. So what that is telling me, that every time I see n, I'm going to start with 3, I'm going to put it and go all the way up to 7. So this is going to be, okay, so this equals, okay, I'm going to put it down here because not a lot of, I can do it, 5 times 3 minus 2. So I started with 3 because of that there. But make sure you put these in parentheses or brackets to realize that that has to be worked together. And then I'm going to add, and I'm going to go to the next one. Now I'm going to go to 4. So I have 5 times 4 minus 2 plus, and I'm going to go down here a little bit, 5 times 5 minus 2 plus 5 times now 6 minus 2, and lastly plus 5 times 7 minus 2. Okay, so again with this, and I'm going to go from 3 to 7, so that's why I stopped. And so now I got to take each of these and figure out what my solution is. So the first one here, 5 times 3 is 15. 15 minus 2 is 13. Plus, this one here, 5 times 4 is 20. 20 minus 2 is 18. This one here, 5 times 2. 5 times 5 is 25, minus 2 is 23, plus 5 times 6 is 30. 30 minus 2 is 28. And then lastly, 5 times 7 is 35, minus 2 is 33. And then when you total that up, you get 115. Okay? All right. So I'm going to pause the video and see if you can work this next one and do it all out and see what you can get. And when I pop it back up, you'll see what I've accomplished. So try it for yourself. Okay, so I just spread it out. And I know that I had to go from 1, j was equal to 1, and it goes up to 6. So every time I had something I had to put in j, I've squared it. So I got 1 squared plus 1, which is 2. Then I had a 5. Then I had a 9 squared is a 10. Then I had, sorry, lost my train of thought, a 17 plus 26 plus 37. And that came out to a 97. Okay? All right. So right here below are just rules for consecutive integers. So like that one we did earlier where it was like 1 to 100, you had to add 1 to 105. So you're doing consecutive 1 plus 2 plus 3 plus 4. That's what this is doing here. But they're telling you it's going to the nth term. Okay? So for consecutive numbers, you don't have to add that all up. It's telling you it has this rule right here. That if I know what n is, I can put it here, and I can put here n. Add it to 1, multiply by the n, divide by 2. So, for example, when we did the one earlier, we had to go 105. Okay? So what happens here in the summation, I would still be 1, n would be 105. Okay? And then what you can do is then you have that I. So what that equals to us, we only have to take is do 105 times 105. Oops, sorry about that. 105 plus 1. Oh, divide by 2. And it works for every consecutive integer no matter where you're at. And so you would do 105 times 106, divide by 2, which roughly, that's a big number, 5,565. Okay. Now this one would be for, the next rule is when you have the rule, is a consecutive squares, you would get, this would be the squares, so you would put that in there and find that out. And this would be cubes. It has to be the sum of cubes. Okay. So then this is the cubes. Okay. So I want to add to your notes about writing these. We've been like looking at the sigma notation and how to use it, but I want you to be able to go backwards and write with it. Okay. So I'm going to go back to page. Okay. So what we're going to do on this page is we're going to actually use our calculators now to solve these summations instead of using it by hand, okay? So the first step that you're going to do, so the first step is to go to math. Math is over here, okay? Then go down to the 0 to find the summation. So if you go down, you can either type in a 0 or arrow down to 0, whichever way you want to do. And if you'll see the summation symbol there. And it says summation, and hit enter. Okay? All right. The next thing so you're again looking for that. The next thing you're going to do is that you're going to we're going to use the letter X as our index of summation. So your calculator doesn't allow you to just do any variable. You can, but you don't know what's stored in there, so it's best not to. So for here, for X, we're going to use that J instead of we're going to use x instead of j. Okay, so over here, you just have to go over here to the x, which is next to, which is next to alpha, and just put x. You don't have the alpha, that was an accident. Okay, next you're going to put exactly what you see. Okay, so I'm going to put in the values for, oops, someone highlighter. So put the values, put the in for the bounds. Okay, so our bounds were 30. And you arrow up to get to that top one to 100. Okay, and then now put the expression that they have there. So our expression for us is 4. So next, enter the expression. So if I go over here, I'm going to hit a 4. Okay, and then we're going to hit enter, and their answer is 284. Okay, you don't have to show the work in it. One thing you're going to say, if it's like, so both things have none, you're just going to use your calculator. Okay. So the next thing we're going to do is we're going to do the 5k plus 1 and plus 3. Now, the thing about calculating, using the calculator, make sure that you enter what you see exactly. But one thing nice about it, it'll have that parentheses for you. So if you're going to, again, we're going to go to math. I'm going to hit 0 because it's automatically going to pop up. Again, you can arrow down to 0. I'm going to use the X button, and my bounds is from 1, arrow up to 100. And in parentheses, I'm going to do 5, and I have to do X because that's what the thing is down there, plus 3. And get out of that by using your parentheses again, and then hit enter. And that gave us 25,500. Okay, last one for this one. Again, we're going to hit math. Again, I'm going to go to just hit the 0, or again, you can arrow down. Let me just arrow down this time. And there's 0, hit enter. My X value will go there. I'm going again from 1 to 200. And I have 9. And then I need to do the X for there. And the square is over here by the comma. Hit enter. And then we went 24,180,300. Okay. Now, I'm going to show you, I'm going to do one more with you. And this is actually from your homework, mostly because I want to make sure you understand how to enter a very long summation notation in there, okay? So here is the example. I'm not going to do like a, I'm not going to enter the calculator. I just want to make sure you know what to make sure that you understand what it looks like. So if I have 9 summation of k equals 1, and then my expression, I would like for you to substitute, and it looks like this. Oops. I'll divide it by 10. Now, we do not use braces or brackets in a calculator. Brackets mean something else mathematically, dealing with vectors. And I don't even think we use braces in a calculator. I'll be honest with you, I've never used them before. So what I want to do is kind of just rewrite this so when you put it in your calculator, you'll know what it looks like, how to do it. But everything that you put in here should look using parentheses. So I have this, There's for my brace. This one's for my bracket. 3 minus. There's another parentheses. K divided by 10. Squared. Close my bracket. Another small parentheses. And then close my brace. Okay. So these blues go together, these reds go together, and all these greens go together. So just make sure that when you enter that, you can see that a little better. That's what you're doing there, okay? Take away all those brackets and braces and put it in like that, okay?